Hi guys, this is a simple and short video about how to read the position signal from the servo-motor Parallax Feedback360 High Speed. It is mounted on an Arduino. The red wire is connected to the 5V. The black wire is connected to ground. Just trying to focus here. Alright, red wire on 5V, black wire on ground. Here we have the white wire on the pin 6. We're not gonna need it though. This white wire is the signal that the Arduino sends to the motor to control the speed. It is a PWM signal in which the duty cycle of this PWM corresponds to the speed of the motor. But we're not going to use this pin. We're going to rotate the motor by hand to make things simple. And the yellow wire we do need. This yellow wire is exactly the position signal that the motor sends. It is important to understand that this position signal is not a simple analog signal or a simple encoder that sends a pulse for each fraction of rotation. No, it is actually a PWM signal that the motor sends, in which the duty cycle of this PWM signal corresponds to the rotor position. This PWM signal is 910 Hz, and it's all explained in the datasheet of this motor. So here in the screen you have the code for the Arduino, and on the right you have the code, and on the left you have the serial monitor that shows the duration of the PWM that the motor sends as the position signal. So how does the code work? First, I made this declaration. The yellow wire pin is pin 3, and I also made this variable called duration, which is an unsigned long. And then in the setup you start your serial port, just so that you can read it on the screen like I'm reading here, and you assign the yellow wire pin as an input, because for the Arduino this yellow wire pin is an input. The motor sends it as an output, but for the Arduino it is an input. It's not very complicated. Then in the loop you use this function pulse in to read the duration of the pulse sent by the motor through the yellow wire, and then you print in the serial the duration of this pulse. It is printing the duration of the pulse in microseconds. So the duration of the pulse corresponds to the duty cycle of the PWM, which corresponds to the position of the rotor. So let's see it happening in real life. The rotor is pointing down in this reference I set up here, and in this position it corresponds to a small pulse duration. And as I rotate it, I hope you can see it on the screen, the duration of the pulse increases. In this position, approximately 180 degrees away from the other one, you can see that the position signal, the position signal is sending a pulse with a duration of around 540 microseconds. And you go all the way it has increased, and here is pretty much the maximum. And when I rotate it further, it goes back to the beginning. So I hope it helps you. and good luck on your projects. Just to make things clear, this code that I'm showing to you, you can find it on the datasheet of the motor. I did not invent this code, I cannot take credit for it. And that's it guys, just read the datasheet for the motor and it should be all in there. I'll try to put the link of the datasheet on the description of the video. See you guys, good luck on your projects.